Hey chemistry class, today we're going to talk about some molecular overall ionic and net ionic equations. Basically what we've been doing so far is we've taken two ionic solutions as reactants and converted them by switching the cations around to get two products that switched. So here's describing the reactions in the aqueous solutions. How do we actually do it? What's going on when we put these things in water, and if I put them in solution, remember it doesn't conduct electricity. They're not ions if it's a solid substance, but if I dissolve them in water, that's why we're calling these aqueous. They're dissolved in water, then they actually will conduct electricity because the ions break apart. So basically what happens is we're showing what's going on. So we will be showing what the ions are doing in solution with three types of equations. The first type of equation is called the molecular equation. This shows all the compounds for the reactants and products. So molecular equation shows all compounds for the reactants and products. And if you think about that, that's exactly what we've been doing for the last few days, is we show the formulas of the reactants and the formulas of the products. So that's what we're doing again. So if I look at this and I say I'm going to put some lead nitrate, aqueous lead nitrate, with sodium sulfate that's aqueous, so they're both in solution, what will I get out? And if we look at this as it's a white powder plus a white powder dissolved in water, so if I dissolve both of these in water, what will happen is I switch partners. So the lead switches places with the sodium to produce lead sulfate and sodium nitrate. Solubility rules is this nitrate's not a precipitate because we got this white precipitate here. So which one is the precipitate? Sulfates don't normally dissolve, so it's lead sulfate. If you look at this, it's basically just the reactions you've been writing. So it's compound plus compound yields two new compounds by switching the cations. You've been doing that, so I feel like we can move forward. What the next part is, whoa. What the next part is a complete ionic equation. So it shows all the ions separated but keeps the solids together as the compounds. So basically what we're showing in the complete ionic equation are all the ions that are separated, because when we put them in solution, again going back to the demo, it conducts electricity because the ions are free to move. So we're going to show the ions present, but we're going to put the precipitator, the solid substance, the insoluble substance, keep that together. So if we look at what we did before, we had lead nitrate plus sodium sulfate yields lead sulfate solid and sodium nitrate, which is aqueous. So what happens on this is the lead and the nitrate ions separate. So we have lead plus 2 aqueous plus 2 nitrate minus 1 aqueous plus 2. Now remember, the 2 is around the parentheses, so that subscript comes up, but not from the polyatomic ion, because nitrate doesn't break apart. It's the same on both sides. And then 2Na plus 1, because there was an Na2SO4, so it switches to 2 because we bring the 2 out in front. The difference here in your explanation is the subscript says that those things are bonded together. Well, if we have two positively charged things, they're not going to bond together. Therefore, we have two separate sodium positively charged ions floating in the water, if you can visualize that. And then we have a sulfate minus 2 ion floating. So we basically have those four things floating, and what happens is the lead finds the sulfate, makes the precipitate lead sulfate, leaving us with, on the right side, 2 Na pluses and 2 NO3 minuses, because they're still aqueous, meaning they're dissolved in water, so the ions are still present. So what we call these things that are the same on both sides are called spectator ions. I know a lot of you guys are athletes or you like going to athletic events. Spectators really don't have a lot to do on the floor. So what we say they're spectator ions because they do not participate in the reaction. So They don't participate in the reaction, they're just there. I know some of you guys think that the fans make a huge difference. Okay, they might be a slight difference, but a focused team, it's not like the fans can get down on the court and play basketball or do gymnastics and do the flip for it. They can help influence what's going on the inside of the team, but I'm saying it's not, they're just standing back watching. They're not actively involved, even though some people think they are, but they're not. So they're called spectator ions. So if I look through here, it's kind of like math. If they're the same on the left as they are on the right, you can cancel them out, right? So lead plus 2 is not the same, but if I look at two nitrates, I have the two NO3s on the left and two NO3s on the right. Now, I'm sorry for apologizing. Once we cancel them, we get a net ionic equation. Now, you guys may get a paycheck now. Some of you do, some of you don't. But without taxes, you get all of your money back. Now, I have a gross income and a net income. The gross is what I earn. The net is what I get to take home. That's my check or my direct deposit every 2 weeks. So it's not as much because it's what's left. It's what I get to use. So net ionic equations is what actually takes place in the reactions. So if I look at this, it only shows what makes the precipitate. So it's only showing what's involved in the chemical reaction. It's only showing the players of the contest. So whether we like it or not, the athletes, it's the team. You don't take, well, some people take team pictures with the fans, but ultimately it's the team on the court that's determining it. So net ionic equations is what's making the precipitate. So I canceled out the sodium nitrate. I get Pb plus 2 plus SO4 minus 2, and there's 1 on each side, so I'm good with that balanced equation. That's called the net ionic equation. So here's an example for you, which is probably really important. We're going to write a molecular and overall ionic, a net ionic equation for the reaction of potassium hydroxide and aqueous iron 3 nitrate. So if I have to write potassium hydroxide, it should be KOH AQ, because it's aqueous, plus Fe, which is a plus 3, parentheses NO3, parentheses 3, because nitrate's minus 1, aqueous, yields, switching the partners around, I should get K, NO3, and iron hydroxide, which is FeOH, in parentheses 3. So if I look at this is called my molecular equation. It's just what we've been doing so far. Hope you guys know that we can look up the fact that nitrate is always soluble, so it forms a precipitate. Hydroxides form precipitates more readily, especially with transition metals. So it's the solid. So that's the molecular equation. We've been writing those all along. The second equation is the overall ionic. Since the word ionic is in there, we're showing ions. Every time you show ions, you must show the charges. Okay, so the overall ionic equation is I'm going to split everything up on the left because they all form ions on the left. So I'm going to have a 3K plus 1 aqueous plus 3OH minus aqueous plus an Fe plus 3 aqueous plus 3 nitrates aqueous yields 3K pluses aqueous plus 3 nitrates aqueous plus, leave that whole solid piece together, is FeOH in parentheses 3 is the solid. So we keep that together. And if we look, we split those up, and now we're going to cancel spectator ions. The spectator ions are the same things that are on the left as they are on the right. So your K is the same, but so we're going to cancel out potassium. We're going to cancel out nitrate because they're the same on both sides. So that's the overall ionic equation. So we cancel the spectators, so they're gone, and the only thing that's left is called our net ionic equation. So the net ionic equation is what's ever left after you cancel the spectators, whatever makes the precipitate. In this case, it was 3 hydroxides, aqueous, plus iron plus 3, aqueous, yields FeOH3 aqueous. So it's kind of simple, I think, in my eyes, but I'm the teacher. So you basically write the overall equation like you normally do. Split all the ions up, show their charges at their ions, leave the solid hooked together, cancel spectators, and write your net ionic of whatever's not canceled out. Thanks. Have a good day.